Okay, hello there. In this video I'm going to show you how to use tree diagrams to solve some probability problems, and I'm going to try to use some current events to illustrate some of the problems. So here we go, let's get started. Okay, so let's look at this problem. So we've got Clinton and Trump, and we're going to say the question I'm going to ask is how do we use these trees to solve some probability problems? First of all, for probability trees, when you have these branches, that's why they're called trees, because you have these branches here, they're called complementary events. And so the sum of the branches have to equal 1, because that's the sum of the total probabilities for all the outcomes. So I know this isn't completely true because there are some other candidates besides Trump and Clinton. And also with polls, there's a margin of error. But when we do probability trees, these have to add to 1. Okay, so for that case, and I know there's probably going to be some people that disagree with the concept here, but the math is that that's going to be 0.52, Clinton's chance of winning, because this has to add to 1. Okay, now these next branches are for like another event, so that's for the presidency, and then the next event could be something else, such as Armageddon. So that's the one I'm using. So suppose Clinton is elected. We've got 2 chances here, and I'm making this kind of grim. There can be Armageddon, or there could not be Armageddon. And the same goes with Trump. Okay, there could be the end of the world, or there could not be over the next 4 years. And I'm going to be really pessimistic in this video, and let's say if Clinton gets elected, there's a 55% chance of the end of the world. And if Trump gets elected, let's say there's an 80% chance. Let's say there's a greater risk. Again, I use my complementary events in that if the chance of no Armageddon is 45% for Clinton, because these add to 1, or 100%. And the same for Trump. If that's 80%, that's going to be 20%. Okay, so what a probability tree does is it's able to help you with outcomes. So you've got possible outcomes here, and you read across the probability tree. So one outcome is you've got Clinton and end of the world, Clinton and Armageddon, or you could have Clinton and no Armageddon. Okay, you could have Trump, T for Trump, and A for Armageddon, or you could have Trump and no Armageddon. Okay, we don't want Armageddon, by the way. So, moving on, let's say we have a question, and let's say I pose a question. Find the probability of Trump getting elected and there being apocalypse. So this is one of the easiest ways to solve probability using a tree, is if it's Trump and apocalypse, what that means is I want to find the probability that Trump wins and the probability that there's an apocalypse. So if it's an and type of thing, Trump and apocalypse, that's going to be multiplying those probabilities. Okay? And how I can do this is I just multiply across the trees 0.48 times 0.8. Okay? And I multiply that out, and what I get is 0.384. And sometimes I write it over here, and I'll write it back down here. Okay? So that's probably the easiest part, and I can do that all the way across. So if I said, what's the probability of Clinton and no apocalypse? Okay, so I just multiply across. If I said, find the probability of Clinton and no apocalypse, that means that's going to be 0.52 for Clinton times 0.45, Okay, and I get a value there, which is still to 3 decimal places, I think. I get about 0.234. 0.234. Okay, so probability trees, they're pretty handy because they help you list the outcomes, and then the probabilities are found by multiplying those probabilities along the branches to get that outcome. Okay, so those are, I'd say, the easy type. Okay, now the other type of probability problem you can have from trees, well, there's many, but suppose I say, what's the probability of there just being apocalypse? Okay, no matter who gets elected. So what's the probability that there will be the end of the world? Okay, no matter if it's Trump or Clinton. So how do we how do we work that out? So what I'm asking is, I'm saying, what's the probability? Find the probability that there's going to be apocalypse. Okay, so for this one, we've got two outcomes that have apocalypse. There's Clinton and apocalypse, or Trump and apocalypse. Now that or part is pretty important. So the probability of there being that is going to be Clinton, apocalypse. Okay, or, very important word here in probability of Trump and apocalypse. Now those or probabilities, those increase the likelihood of it happening. And when you increase the likelihood of probability happening, you're going to add them, not multiply them. Multiplying probabilities, multiplying these numbers, this number gets smaller. Okay? Adding the probabilities gets more likely. So that means it's going to be CA plus probability of Trump. Okay. So let's work this out. And Clinton and apocalypse is going to be, I haven't worked that out yet. That's going to be 0.52 times 0.55, which is 0.286. I'll put it up there as well. And I've got Trump, so that's, sorry, that's not the neatest there, that's Clinton's. And then Trump's is going to be, did I figure his out already? Yep, that's just Trump's and apocalypse is 0.384, 0.384. So the probability of either of those happening is going to be Clinton's was 0.286, plus Trump's chances of the end of the world is 0.384, giving me a cheerful total of, what do I get there, 0.67. Yikes. All right. Okay. So not the neatest work here, sorry about that. But yeah, that's how this concept of working those out is slightly different than the other one because it has an addition. Finally, if I wanted to figure out the probability of Trump and no apocalypse, because that's certainly an option, the sum of all these probabilities over here have to equal 1. So if I wanted to work this out, I could do it a number of ways. I could multiply along the branches here, 0.48 times 0.2, or I could add these up and subtract them from 1. Either way, I get 0.096 for the probability of that happening, okay, that outcome. Okay, so we've got 4 outcomes, 4 probabilities. These probabilities add to 1. These complementary events add to 1 as well, and that's just the beginning, part 1. More to come. Okay, thanks for watching. Bye-bye.